Good afternoon. My name is David, and I'm representing a company called LKB Vassara. And I will give you an introduction to the water-powered technology. And I will also give you, hopefully, an explanation why the name of the company is LKB Vassara and not just Vassara. I have a background in Atlas Copco. I've been working in their core drilling division, you can call. Why I'm mentioning that is there are some similarities with this technology and core drilling. There are some advantages with core drilling. You drill straight, you drill safe, you don't damage the formation you drill in. Similar arguments are with this. The main difference is core drilling is very expensive and very slow. Here it's fast, and of course you can be much more profitable using this technology in some certain applications. I will focus this presentation on mining. That's one part of the company, you can call it. Where we are growing more is in more ground engineering applications. We talked about this dam rehabilitation, for example. That's a very good type of project for this technology. But I will focus mainly here on mining. So this is the company. The company name is LKB Vassara. It's a company based in Sweden. We are working with partners and with distributors around the world. So here in Canada, it is Medatech and Steve Archer, who is the main contact person here. The company is relatively small, 50 people working in the company. 10 of them are in R&D, so we are very strong in innovations. We are focusing very much on new products, new innovations. So that's probably why maybe you have not heard more of this technology, is that the sales force is not the focus so far in the company. We're focusing more on the R&D. The reason why it's called LKB Vassara is that we are owned by LKB. LKB is a mining house in Sweden, owned by the Swedish state, doing iron ore production. They need our technology for their mines. Without Vassara, they will not survive. That's the reason why they own the company Vassara. There's no other technology for drilling that can do the same as we can for these two mines they have. So that's the reason why they decided to buy the company, and they also keep the company now for more than 20 years. LKB, 2 mines in northern part of Sweden, in Scandinavia. Very strong in logistics, which you have to be for iron ore production. So they have 2 mines, and then they have a logistics system so they can ship the pellets, that is the final result from the mining production or process. So we have one harbor in Norway going out and one in the Baltic Sea. The biggest mine is the Kiruna mine. It's been in operation for more than 100 years. It's a continuous ore body looking like this. The other mine is called Malmberget mine. It's a little bit different. It's a number of ore bodies. Also a very long production, more than 100 years again. Both mines are using sub-level caving. I believe you are familiar with this. So the drilling is done in a fan shape. It can look like this. You are doing the development or developing, you do the drill arrays, and then you do the production drilling. And the Vassara part is done in the production drilling. The other parts are done with other drilling technologies. But the production drilling is done with Vassara. If we go back, say 25 years ago, LKB had huge problem with the profitability. They were more or less bankrupt. So they have to do something with the whole logistic in the process. because they are mainly competing with big open pit mines, like in Brazil or in Australia. So if you're not good in logistics, you cannot compete with an underground mine in iron ore. You have to have the mass, you have to have big scale operation, otherwise you will not survive. You have to keep the cost down. So they started a project involving a number of different things. Also inside the mine, they improved more or less everything. But a very important part was the drilling, production drilling. To be able to upscale everything, you have to drill long holes. You have to be able to blast big mass every time you blast. So then they came in contact with Vassara, or the people developing this water-powered down-the-hole hammer. Actually, it was 3 guys in Atlas Copco who came up with this idea of using high-pressure water instead of high-pressure air for powering down-the-hole hammers. Atlas Copco were not really interested in this. They have other techniques. They have their compressors and so on, so they didn't really believe in this, but LKB believed in this. So they start working together, forming this Vassara company, and after some years, it was a success. So what they do is they drill. In the past, they drilled like this. They drill with a top hammer technology, and probably you're familiar with top hammer technology. It's rather simple, and you drill very fast, but you cannot drill very long holes. You get a lot of deviation, and you lose the energy, so you don't have much power left if you reach more than 20, 25 meters. So this is what they did in the past. They could not drill very long holes. So then they introduced Vassara, and now they can drill a fan like this. Extremely straight holes, more than double the length. The reason why they have to stop now is that the distance between the top part of the holes is getting too big. Otherwise, the drilling, you can drill probably 100 meters or even more. So that's not the limitation. The limitation now is that the size of the block when you do the blasting is too big if you go bigger, because you're drilling like a fan. And I will come back. Second part of the presentation will show what they are doing in the future, or what they plan to do. This is the limitation now, that you cannot drill longer holes because you get too much distance between the holes. So if we these are just some numbers. This was in the past, before they used the Vassara hammers. So they drill actually not very short holes, but say 28-meter long holes, relatively small diameters. So every time they blast, they got 1,200 ton out. They were using a lot of equipment, a lot of people in the mine, meaning they had high costs. And this was not good enough to compete with the open pit mines. So then they introduced the water-powered hammer. So the water-powered hammer is a down-the-hole hammer that you use high-pressure water to power. We use up to 180 bar if you drill in hard, solid rock. If it's in softer formation, you use less pressure. And the reason why you drill extremely straight is that water is not compressible. So even if it's 1 bar or 200 bars, it's the same volume. So even if you drill with 180 bar, and when you release the pressure coming out of the bit, you have no expansion of the media. So the same volume of water going into the hammer is also going out of the hammer, meaning the water and the cuttings leaving the bit and going out of the hole is going out extremely slow, meaning you don't need a lot of space between the diameter of the hole and the diameter of the hammer. So as you can see on the pictures, all the hammers are with stabilizers or with ribs on the side of the hammer. And the ribs have more or less the same diameter as the bit. There is just between 2 and 5 millimeter gap. And this is the reason why you drill straight. And if you want to drill even straighter, you put the stabilizer behind the hammer. So this is the reason why you drill straight. And then we started this partnership with LKAB and Vassara. The main reason was the straight holes, but then also we find out that there was some other benefits. The water is binding the cuttings, so it's very like fresh air when you are drilling. There is no oil. The hammer is just powered by pure water. There's no lubricants, no oil in the water or in the air. There is low noise level, of course, because you have the hammer in the hole, comparing with the top hammer. And you have the water cooling the atmosphere, so it's a very good working environment for the drillers. And it's of course, very easy to see the operation because you don't have any dust or in the air. These are the arguments for mining. When we come to other applications, it's mainly that you drill in a much more safe and careful way. You don't damage the formation you are drilling in because you don't have this expansion of the media. But in mining, it's mainly that you drill straight holes, and it's a very good working environment for the operators. So now using, we have the similar numbers, but now with the water hammers. They drill with a 4-inch hammer today. They drill close to 60-meter long holes. They have a very good accuracy. So over the 60 meter, they have a deviation of approximately 1%. So extremely straight holes. And as you can see, the most important numbers now is that instead of 1,200 tons per blast, you get 10,000 tons per blast. So everything is upscaled. You use less equipment, you use less people, you reduce your cost, and now the mine is extremely profitable. And this is the only technology that can do this in a cost-effective way. Of course, you can do this with core drilling also. You drill also extremely straight, but then you drill slow, and it's very expensive. So again, less equipment in the mine, and also much better working environment for the operators or the people in the mine, thanks to no dust. So again, if we summarize this, you have increasing the length of the holes, you get a much more profitable operation. So a short video. So this, here you see the drilling and the water coming out. It's no dust, no oil. Water is coming out very slow, and this is another part of the project that most of the drilling is automized. So you don't have, even if it's no dust, you don't really have the operators close to the rigs. So this is how it looks like. This is the water. And here you have the operators. So drilling is one part, but also they have done a lot of things with automation and with logistics in the mine. So this is just showing the working environment at the rig. So no dust, very clean, and very low noise level, even if you don't hear it. Let's see again. So this is the upscaling, making the mines extremely profitable. So again, this is the hammer. It's nothing new, really. It's been now on the market for 30 years. So it's very well proven. They are drilling, I think it's 2 million meters every year in the mines using the 4-inch hammer. So it's very much similar as an air hammer. You have a piston moving up and down, but thanks to the not compressible media, you need some other components also in the hammer. So in this case, we have a critical product in the valve. Maybe you can see it on this. I don't know if you see it. It's a piston moving and it's a valve moving, and they move in a certain way, opening up channels inside the hammer so the piston can move up and down. And if we go really in detail with this, you see how they work. And it's very tight tolerances here. So it needs to be really clean water going into the hammer. Otherwise you will block the channels here and you will have a lot of wear on the parts. And if you have a lot of wear on the parts, you don't get enough pressure on, you don't get the pressure up inside the hammer. So then you have to change the parts very frequently. So water quality is very important for us to get a long life out of the hammer. And this is moving with the double frequency as an air hammer. So we are between 50 and 70 hertz. So really high frequency, meaning you have to rotate the hammer slightly faster than what you do with an air hammer. This is a typical setup today. You have a rig, you have a water pump, you have a water swivel, you have the drill rods, the hammer and the bit. All this you can buy from us, and now also the rig that you can talk to Medatech about, and then you can make a special water-powered or a rig for water-powered drilling. Some clients are using a water pump on the rig. I would say most of the clients are using a standalone pump, electrical or diesel. So it's up to you if you want it on the rig or not. So this is a typical setup today. You can drill in all directions. We prefer to drill in upwards, if possible, because then it's easier for the cuttings to come out. If you drill down, because the cuttings are coming up very slow, there is a risk that the cuttings will stay in front of the bit and slowing your operation. So if possible, we recommend to drill in upward direction. But there's no problem to drill down or horizontal or any direction. So this is what they do today. So now they have started a new project 2-3 years ago to take the drilling into the next level. So what they want to do now is doing this. So instead of drilling a fan, they would drill out, it's still like a fan, but they would like to drill the holes in parallel. So you'd keep the distance between the holes, and then you can drill much longer. So again, in the past, top hammers, short holes, introducing the water-powered hammers, longer holes, and now the intention is to use a coil tubing rig and drill parallel holes, meaning you control the drilling and you steer the drilling where you want to go. So you get consistent fragmentation, you get an optimized draw flow. Because you are using a coil tubing rig, you eliminate the rod handling. So you are very quick in the hole and out of the hole. And the amount of explosives can be reduced thanks to this. In Scandinavia, environmental aspects are very important, so just to focus on this, you will reduce the energy consumption with this, and you will reduce the amount of explosives. So what is important in the project? We can say it's 4 different parts. To be able to do this, you need to have a coil tubing rig. Coil tubing rigs are available on the market, but not many of them are drilling in this direction. Most of the coil tubing rigs available on the market are drilling down. Most of the coil tubing rigs available today are using a very, I don't know the exact word, but a big wheel, because if you drill on surface, you are not limited to a certain space. But now we are inside a mine, so you have to make everything small, and you have to drill up. So that's one part. The other part is the location. You have to know where you are all the time, even when you are drilling. So during drilling, you have to know where you are. You cannot stop and measure and drill and measure. So you have, when you are drilling, and you are drilling with a hammer that is creating a lot of vibrations. So you have to have a tool that can tolerate the vibrations while you are drilling. The third part is the steering. So you have to be able to steer go left, right, and in all the directions you want to go. And then you are using a coil tubing rig, so you cannot rotate the drill string or the coil. So you need to find a way to rotate the bit or the hammer. That's in the bottom of the hole. So that's the fourth part. So this is 4 different areas we're working on today. We are very close to, or we even have solutions for 3 of them. What we now are facing some problems is the rotation of the hammer and the rotation of the bit. The intention was just to rotate the bit, keeping the hammer fixed, but just rotating the bit. Now it seems that we are getting away from that, and we will use like a mud motor behind the hammer, rotating the hammer. The problem is that the mud motors available on the market today are expensive, and they are very long. And we don't have that space because we have to bend in a much shorter radio than what you normally do. So we have to make sure we have a mud motor that is small enough, but still powerful enough. So that's also something we're looking into. So location, you have to know where you are. We will use a gyro type of measuring tool here. And it's working fine today. So there we have a solution. Steering, again, you have a lot of vibrations from the hammers. You have to have a very robust tool to make sure that you can steer. This we also have. And the coil tubing rig, it was not possible to find a rig on the market, so we have designed our own rig, and that's also available now for us. I will show you a picture later on. So the main thing we are missing now is the rotation of the hammer but we will find a solution for that too. So again, showing a video, maybe there is some, there you have some sound. Again, going back, you have the top hammer, a lot of deviation. You have the water power drilling, no deviation, close to 60-meter long holes, but then you have to stop. So in the future now, what the intention is using a coil tubing rig, and drill holes like this. So now you don't drill straight holes anymore, you drill in a controlled way instead. You are measuring all the time where you are, and then you go left or right. So you drill your parallel holes. And the intention is today to drill approximately 100-meter long holes. Then there is another issue. Then you have to put explosives in the holes. And to have explosives in a 100-meter long hole, that's a challenge. So that's another project to get it in and to make sure that the explosive stays in the hole. So that's the full project. We already now see some spin-offs. So even if you don't buy the complete package, you can buy maybe parts. So this is the first product we are introducing. It's what we called Owd Optimization while drilling. This is a tool, a sensor, measuring and making sure that you use most of your energy to break the rock and reduce the energy going back to the rig or back to in the drill string. And we have come up with what we call a Vassara factor. It's a patented factor. It's a very simple. We are just measuring the vibrations coming back. So there is a sensor that you place on the rig and measuring the vibrations. Important for good operation is to have a stable frequency and as low energy coming back as possible to the drill rig. And this is what this tool is showing. So you just put the sensor on the rig and then you measure the vibrations. This you can do very simple, or you can do it very more automated. So you can use just an observation You can put this tool on the rig, and then you can come back and look at the data later on and see if the drilling was efficient or not, and then you can adjust some parameters. Or you use it in an open loop. You following the factor all the time, and then manually you change parameters on your drilling, and then you increase your efficiency. The tool is not exactly saying what is wrong, but it's just saying that you can do it better. So you can increase the water pressure, or you can change the feed force, or you can change the rotation speed. So you play with different parameters, and as soon as you see as the frequency is going down and it's getting stable, then you know that you are doing something right. In the future, and what they do already now in the mines with LKAB, is that they have integrated this system to the rig. So the rig is reading this factor and then automatically changing some parameters to optimize the drilling. So it can look like this. You get a graph, and when you see that the graph is going down, you are doing something right, and when it's stable, you're also doing something right. So this is a tool we today use. Our service technicians are using this when they go out to sites and talk to clients and try to optimize their drilling. They can take this tool with them and just place the sensor on the rig somewhere, and then they have a small computer, and then they get this out, and then we together can optimize the drilling. And we see already now in the mines, when using this fully automated system, this is maybe not easy to see, but this is a drill bit. The blue parts are where you have the wear on the bit. So with the same number of meters, same conditions, you can see that the bit to the left is with less wear than the bit to the right. So just the savings in bit life and the bit cost is today good for the LKAB mines. They are happy with just seeing this, that they can reduce the number of bits. And it's a lot of money just in the bits. So that's a small part. But it's showing that if you optimize the drilling, you get more meters out, you get longer life of the equipment, and you get a more cost-effective operation. So this is the rig today. So we have a prototype rig, or the second prototype rig actually. So everything is working today in the mine. So this, they believe, will be the future of drilling in the mines, in the two mines they have. And then you have the short, this is back to the water-powered hammers. This is the range of hammers we have today, the standard hammers. So you can drill everything from 60 millimeter holes up to 10-inch holes. So, and also this is not, we have not been very successful in getting into mines for production holes. What we see is more easy to get into mines is applications more like this, where you drill like service holes, for example, or special holes in the mines, where you want to drill extremely straight and long holes. You can do this with core drilling, of course. Similar accuracy, I would say, but extremely slow, and you cannot do it in the same diameters that you can do with a water hammer. We can do this up to 10-inch in one run. Or you can even use reaming setup and drill it in 2 or 3 steps and get relatively big holes. So this is what we see in more mines around the world doing this kind of drilling. This is just showing some references. We are all over the world doing this. But to summarize everything, this is the mining part we have talked about now. Where we are growing mainly today is in what we call ground engineering. So all the major players, I would say, in the world, it's with focus in Europe and in North America, are using this technique for different applications within ground engineering. It's for grouting, it's for foundation, dam rehabilitations, for example, is a very important part for us. Where every time you want to drill in a safe and careful way, this is a very good technology for it. But that's for another presentation to show you what they are doing. So I have been focusing now on the mining part, but that's, again, a small part of what we are doing today.